We're going to continue our coverage of Java completable futures by first describing something known as Java futures. And Java futures are a feature that's been around for a while, gosh, about almost 20 years at this point, and they provide the foundation for Java completable futures. We'll also talk about a human-known use of using Java futures, which is kind of fun, and I'll give you an overview of the key methods in the Java future interface, which, not surprisingly, also appear in the Java completable future interface, even though that's not usually the typical way you use them. So a future, in general, not just in Java, but in general, is a proxy that represents the results of a call that's invoked and which runs asynchronously. And if you've ever programmed with JavaScript, you might be familiar with the concept of asynchronous calls and futures. There's other languages that have futures, other patterns that involve futures as well, such as the active object pattern. Typically what happens is a client invokes an asynchronous operation. That asynchronous operation or computation runs in some background thread somewhere, some service thread, and what comes right back to the client is a future, and the client can use that future to obtain the result when the asynchronous computation completes. So client invokes an operation, gets a future back, call runs in the background, and then at some point in the future will be triggered, and you can get a result back after the computation completes. And there's some subtleties to this that we'll talk about as we get further into this. There's some really fun examples of human-known uses of futures in the context of fast food restaurants. And these are typically, historically, have been conveyed through table tent numbers or table number stands. Nowadays, you're more likely to get a piece of paper with a number written on it, but back in the day, and at some restaurants, you'll still get these little plastic tokens of some kind. If you ever go to like a deli where you order and then they bring you your food, you typically get some kind of table number stand like this. And a good way to compare and contrast the difference between various approaches to fast food restaurant service is to compare and contrast the traditional McDonald's way of preparing food and the traditional Wendy's model of preparing food. So hopefully you've had some experience with McDonald's and or Wendy's. Hopefully not too much experience because it's not very healthy for you, but at least it'll give you a feeling for what we're talking about. So let's talk first about McDonald's. So in the McDonald's context, historically, and this is not necessarily true anymore, but back in the day, McDonald's would pre-cook food like hamburgers and French fries and maybe pour some drinks. And then they would cache that food in heat lamps behind the cash register area. And if somebody came up to order a Big Mac and some fries and a Coke or whatever, then that transaction took place synchronously. And the person would order the meal, they'd pay their money, and the clerk would turn around to the heat lamp, grab the Big Mac, grab the fries, grab the drink, and deliver the food right then and there. So that's typically what's known as a synchronous transaction or a rendezvous style model. And of course, the goal of that was to try to minimize the amount of waiting time at the cash register, because that's what generates the revenue. The faster you can get the people through, the faster you can make money. And so by pre-cooking the food and caching it, you could go through a little quicker. The problem, of course, with that style of model is the food has been sitting in a heat lamp for a while, so it may not be as fresh as you might want. And God help you back in the day if you wanted something special. When I was a little kid, I used to want McDonald's hamburgers with no ketchup or mustard. And that really threw them for a loop because they didn't pre-cook those. So they had to make those specially, so it took forever. So an alternative model is the Wendy's model. And this was actually one of their selling points at one point. Again, things have changed over the years. But in the Wendy's model, it's cooked to order. And it's done asynchronously. So the way it works is you go up to the cash register, you order your Dave burger or your Wendy burger or whatever it is. You order your Wendy's hamburger and whatever else you want, maybe onion rings or whatnot. And rather than having you stand there synchronously waiting to get your food, instead they give you back a table tent number or a piece of paper with a number on it or whatever, which plays the role of a future. And then the cook goes off and cooks your food to order. They don't pre-cook it. And then at some point, you get your future redeemed. And there's typically two ways of doing that at a place like Wendy's. One way to do it is to have a pickup window, and you walk back periodically and say, hey, is my order ready yet? That's called the polling model. You poll to get your result. And the other model is a callback model where you sit at a table and you put your number out there and then they come out and bring it to you. Wendy's probably did more of the polling style model, but the basic point there was that rather than making people block synchronously at the cash register, they would take care of just a little tiny bit of the transaction synchronously, give you some kind of future, send you on your way, and then you would pick your food up or someone would bring it to you later. So two different ways of being able to do transactions. And not surprising, that's not unlike the way that things work in computing. For the same reasons, we're trying to maximize throughput, maximize performance, minimize latency, minimize waiting, and so on. So the futures model, of course, is the Wendy's model. So let's talk about the Future API. The Future API was added in Java 5, which came out in 2004. And that's where they first really had serious built-in support for asynchronous method invocations. And there's this future interface, you can see here. And the methods in the future interface, canceled, is done, and get, are designed to help manage a task's life cycle after it's submitted to be run asynchronously. And we'll talk more about how that works shortly. But the basic idea is there's some APIs, such as the thread pool executor, which is the heart of some of the Java traditional thread pooling models. And you submit some task to run asynchronously, and the task is going to give you back a future, and then the computation runs in some pool of threads or in some background thread. The other main thread goes off and does whatever it does, and at some point it picks the result up from the future. So there's several things you can do with the Future API with respect to lifecycle management of the tasks that are submitted for computation. One is you can say, is the asynchronous task finished? Is it done? And implicit in there is it done, yes or no. Now, you don't know whether it succeeded or failed, but you know it's done. What its status is something that happens later. Something else you can do is you can ask the future, has someone canceled this future already? It could turn out that after you submit something, you want to cancel it because you no longer want to wait around. Like, let's say you put in your order and it takes too long, and so you cancel it. That kind of thing happens all the time with delivery services like Amazon, where something gets lost or they can't fulfill your order, so you cancel it eventually. So you can check to see if the future's been canceled. What that really means is, has the asynchronous computation been canceled via the future yet? And if not, you might decide to cancel it. So that's something else you can do. You can test for cancellation, and you can cancel the task that's running. Something else you can do, and the most common thing to do, is to get the result. And there's a couple of ways to get the result. One is to call get, where you're going to block until the result is there or until it fails. And the other way is where you're going to block for a certain amount of time. And you can dictate how long you're going to wait to get the result. So that's kind of akin to the Wendy's example of going up to the pickup window and saying, hey, is my food ready yet? And if the answer is no, then you could either wait there for a certain amount of time. You wouldn't wait there forever, probably. Or you could decide that you were just going to poll and you'd go back and talk to your friends or text somebody or read the newspaper or whatever you're going to do. The Java Future interface provides the foundation for Java's completable future class, and it does that by having the interface implemented by completable future. So you can see some of the methods that are in completable future, and there's a bunch of them as we'll talk about shortly, happen to be the same ones that come from the Java interface, and that's because it implements the Java Future interface. However, and this is the key thing, the completable future class defines dozens and dozens of more methods that do more powerful things than you get out of the box with futures. And that, of course, is what we're going to talk about here next. So that's just a quick overview of Java Futures and the Java Futures API, and give you a little analogy to everyday human-known uses of these concepts.